Hi students, in this video we are going to look at air and atmosphere, which is really a very small topic and it's mostly memory work. Okay, so the composition of air, so the surrounding air around us, is made up of 78% nitrogen, N2, 21% oxygen, O2, and then 0.03% carbon dioxide where you breathe out. Right, and then the other 1%, because 0.03% is very little, right? This 1% is actually made up of noble gases such as argon, water vapor, and of course your carbon dioxide gas. Okay, so this percentage we have to remember. Okay, so this is the normal percentage, but at some point of time, there could be an increase in what we call pollutants in the air. Okay, so common pollutants, we have your carbon monoxide. Okay, where is carbon monoxide formed? This is formed from incomplete combustion of hydrocarbons. Right, so these hydrocarbons is under your organic chem. Basically, these are fossil fuels where you dig up and you burn them for energy. So if it's incomplete combustion, you will get carbon monoxide as one of your products. Complete combustion, you will get carbon dioxide as your product. Okay, so the effects of carbon monoxide is a poisonous gas. So it combines more readily with hemoglobin to form carboxyhemoglobin. So hemoglobin is found inside your red blood cell and it is used to bind oxygen. Okay, but instead of binding to oxygen now, if there is carbon monoxide present, it will bind to carbon monoxide more readily instead. And it is an irreversible reaction, meaning to say after the hemoglobin bind to carbon monoxide, they cannot give up the carbon monoxide, so it's irreversible. So as a result, your hemoglobin, which is supposed to transport oxygen, is going to transport carbon monoxide now. So as a result, there is not enough oxygen, and this could lead to death. Okay, oxygen is needed for respiration to produce energy for us to do our daily life activities. Okay, so carbon monoxide, this is removed by redox reaction via catalytic converters. So catalytic converters are usually installed in the exhaust pipe of your cars and factories, chimneys and all that. Okay, so the two common catalytic converters we have to know is your transition metal, rhodium and palladium. Okay, so what is happening is my carbon monoxide, okay, it will promote the oxidation of carbon monoxide with the oxygen that's just in the air naturally to give you carbon dioxide gas. So CO plus O2 give you CO2 and then balance out your equation. And CO2 is naturally occurring at 0.03%. It's non-pollutant. Okay, the next pollutant we are going to look at is sulfur dioxide. So SO2, okay, sulfur dioxide is come from volcanic eruptions. Right, so your lava and all that, there's like sulfur content on Earth, and once your volcano erupts, this sulfur will react with the oxygen in the air to form sulfur dioxide. Okay, it is also formed from burning, your combustion of sulfur containing fossil fuel in power plants. Okay, so this fossil fuel is usually containing carbon and hydrogen, but sometimes it can also contain sulfur. So when we burn these fossil fuels for energy, right, the sulfur that's present inside the fossil fuel is converted to SO2. Okay, SO2 is acidic. This one is your non-metal oxide. Non-metal oxide is acidic. This is your acid-base chapter. Okay, so it dissolves in rainwater to form acid rain. Okay, in the form of sulfurous acid. So this equation, same thing we have to know, yeah? SO2 plus H2O give you H2SO3. Sulfurous acid is one oxygen less than the sulfuric acid. Okay, so sulfurous acid plus more oxygen can give you sulfuric acid. Right, so this is your typical strong acid. Okay, so with this acid that's present and the rain falls down, it will form acid rain acid rain. And what will it do? It will corrode buildings and limestone, meaning to say like your statues and all that. Okay, so if they say what's the effect, please don't just tell me, oh, SO2 is acidic from acid rain. What's the effect of acid rain? We have to write. Okay, so corrode buildings, decrease soil acidity, so it's unsuitable for growing crops. And then it will leach into the river, it will affect marine life, right? So acidic waters, your fishes cannot really survive. It is also a poisonous choking gas and it will cause respiratory problems. Okay, so how do we remove the sulfur dioxide, harmful pollutant gas, right? We use calcium carbonate or calcium oxide. So your calcium carbonate, when you heat it, it will give you calcium oxide, which is your metal oxide. Metal oxide is a base. So base can be used to neutralize something that's acidic. Okay, the process is called flue gas desulfurization, and the CaO is added to the chimneys of your power station and factories. Okay, so calcium carbonate, CaCO3, right, plus the sulfur dioxide can give me a salt, CaSO3 plus carbon dioxide gas. Okay, so essentially this is swapping the partner, but SO2 is a gas by itself. You cannot just swap it directly. So it will form SO3, 2-, your sulfide ion. So you get your calcium sulfide, which is a salt, and carbon dioxide gas, which is naturally occurring. Okay, your CaO and SO2 base plus acid reaction give you a salt, calcium sulfide again. Okay, calcium sulfide plus more oxygen can give you your calcium sulfate, balance out your equation. And then calcium carbonate plus sulfuric acid, H2SO4, can give you calcium sulfate, carbon dioxide, and water. Okay, so these 5 reactions, just remember, overall we are trying to convert the products or the reactants, your SO2, to to non-pollutant. So your pollutants is converted to salt, and salt, which are neutral and they are non-pollutants. Okay, the other pollutant we are going to look at is your oxides of nitrogen, so NOx. Again, this is a non-metal oxide, acidic. Okay, so this is formed by lightning, right? Because naturally occurring, we have 78% nitrogen. So when lightning strikes, your N2 will react with O2 over here to form 2NO. And 2NO, even though it's neutral, it can easily be oxidized to give you NO2, your nitrogen dioxide, which is acidic. Okay, so NO is neutral, however, it is easily oxidized to NO2. NO2 is acidic, same thing, it dissolves in water to form acid rain. So for NO2 plus H2O give you HNO3, your nitric acid. Okay, so this formula is not so difficult. Just remember acidic gas plus water give you your nitric acid and then balance it out ultimately. Okay, so same effects as SO2, meaning to say it corrodes the buildings. It makes acidic marine water, so your marine life is difficult to survive. It causes acidic soil, so crops cannot grow, etc. Okay, so this we also remove it by catalytic converters. Again, this is your rhodium and palladium. Okay, so NO converted to N2 and O2 non-polluting gas. NO2 converted to N2 and O2 non-polluting gas. Just balance out your equation. NO plus CO, pollutant and pollutant, converted to N2 and CO2, non-polluting gas. Okay, NO2 plus CO give you N2 plus CO2, non-polluting gas. So just remember at the end of all your reactions, right, if there's carbon, it will give you carbon dioxide. If there's nitrogen, it will give you nitrogen gas, which are naturally occurring. So these are the non-pollutants. At the end of it, you just have to balance out your equation. You don't have to really memorize it. Okay, so we have methane, CH4. This is also a naturally occurring gas. This is found through decay. So when living organisms die and your bacteria go and decompose them, right, when during the decomposition process, methane, the CH4, will be given out. Okay, it is also given out via cow flatulence. Okay, so when cow releases gases, the gas that comes out is methane. Okay, carbon dioxide and methane, these are the most common greenhouse gases. Okay, what do greenhouse gases do? They trap heat at the lower atmosphere. Okay, so this one, right, helps that our atmospheric level doesn't get too cold, you know, because it traps heat. However, if there's excess greenhouse gas, then excess heat will be trapped. And this one will result in global warming. Okay, we have to write this down, yeah? So with excess greenhouse gas, there will be global warming. Your ice caps will melt, you know, your coastal areas will flood, etc. Okay, so what do? We reduce the combustion of fuels by taking public transport, meaning to say we minimize CO2 production, or use alternative source of energy, such as wind energy, solar energy that doesn't produce any CO2 gases. Okay, unburned hydrocarbons. So again, hydrocarbons are fossil fuels that we dig out from the soil. Okay, and sometimes when we burn it, we have incomplete combustion, and incomplete combustion, okay, will produce pollutants such as ozone, NO, CO, and CXHY, so your unburned hydrocarbons. And all these pollutants will join together to form what we call smoke or haze. So smoke and haze, what's the effect? It irritates eyes, nose, your throat, and it also damages crops. Okay, so same thing, what do we do with this, the NOCO, etc.? We remove it via catalytic converters, your rhodium and palladium. Okay, ozone, right? The formula is O3. This is actually a naturally occurring outer atmosphere layer. So at the outer atmosphere, we have a layer of ozone that prevents excess UV light from reaching Earth. Okay, but if there is ozone in the lower atmosphere, right, it will react on sunlight. Okay, with sunlight, right, this ozone can break down again to form your smoke. So the ozone, if it somehow reaches the lower atmospheric level, okay, then it will actually react with the sunlight that's around here, and then it will form like your O2 and oxygen atom. So all these will actually trigger a reaction to form your photochemical smoke. Okay, so same effect, smoke will then irritate your ENT, as well as it damages crops. Okay, last but not least, we have your CFC, so chlorofluorocarbons. Okay, CFCs are usually produced in propellants, refrigerant coolants, and they have been banned. The fridge itself will give out CFC. So CFC have this effect of forming what we call a free radical, like a chlorine atom. Okay, and then when it is exposed to UV, right, again, this will react with the ozone and it will remove this ozone layer. So your ozone layer prevents excessive sunlight from reaching the Earth. You know, if there's no ozone, then, you know, we will have what we call scorched Earth. You know, the Earth will be too hot for even human beings to survive. Okay, these are all the pollutants that we are going to look at.